All right, so we're ready to take that barium chromate and not dissolve it in pure water, but dissolve it in a solution that contains sodium chromate. Now, what I see students do when I have looked at where they're making mistakes, they try to take those two salts and react them and do some type of precipitation reaction with them. You're not going to do that. You're interested in the molar solubility of barium chromate. You write it dissolving and not try to interact it with the sodium chromate. Where it's going to come into play is in this table. Okay? There's nothing that changes about our expression. It's barium's concentration times chromate's concentration, right? We just need to know what sits in this E line so we can plug it into here. So let's see. We dump some of the solid into solution. Before it has a chance to dissolve at all, there isn't any barium, but if you look at the sodium chromate, there is some chromate, and we can put a number in here. All right, so let's come over here and let's just consider what sodium chromate is doing. When sodium chromate dissolves, it is going to 100% break apart into, because it's not an insoluble salt, that ion plus one chromate. So if they tell me the concentration of sodium chromate is 2.6 times 10 to the minus 3, then the sodium concentration is 2 times that number, but I don't care about the sodium concentration. It's not over here. But the chromate is going to be the same value. You get one of these for every one of the sodium chromate. So I'm going to place in this table, and this is where common ion problems show up. You put in how much is already there from that sodium chromate solution. And then your change line doesn't change. We have the minus S, the plus S, and the plus S. So then we have sum, we have S, and we have 2.6 times 10 to the minus 3 plus S. Plug some information in here. I have a KSP of 2.1 times 10 to the minus 10. I look at my E line, I see that barium is S, and I see that chromate is 2.6 times 10 to the minus 3 plus S. Okay? Well, we could do the quadratic if we really wanted to, but let us make an assumption. Let's try it anyway, because it's always better than a quadratic. We're going to assume that S is much, much smaller than 2.6 times 10 to the minus 3. That's a little iffy, because that's a pretty small number. But we do know that this common ion makes it even less soluble, so maybe it'll work. I'll ignore that little S. So I'm going to scribble it out, okay? And so now we know that S would be 2.1 times 10 to the minus 6 divided by 2.6 times 10 to the minus 3. That will give me a solubility value of, what have I done? Oh, I made that a 6. I don't know why. Getting tired. Okay, 10 to the minus 10 divided by 10 to the minus 3, and it gives me 8.1 times 10 to the minus 8. Always check your assumption. Is that a lot smaller than this number? Yes, it was a good assumption. All right, so now that is the molar solubility of this product, of this barium chromate. Now, what did we say a common ion does? We said that when you add a common ion, it decreases the solubility. In the previous video, when we did it in pure water, we had a value for the solubility of 1.4 times 10 to the minus 5. That is the solubility of it in pure water. Did that decrease the solubility? Well, yes, that's a much smaller value than with a raised to a minus 5 power. So, common ion problems, you put the concentration of the ion into the I line in order to work the problem. Now we're going to do a little pretend, all right? We're going to pretend for just a moment that this is not the formula for sodium chromate. This is a wild thing to say because charges don't work out this way. But what if this was this instead? Okay? There were 2 chromates in this compound. That means it would break apart into sodium plus and 2 of these chromates, right? So if you started with this concentration of the whole thing, then what would be the concentration of chromate? Well, it would be 2 times that 2.6 times 10 to the minus 3. I would produce 2 of these for every one of those, and that number would go right here instead. I say this because sometimes students will say, okay, I know this. I'll just take whatever concentration of the common ion or the salt and put it right there. It'll work if the number of those ions is the same as the number in the compound. There's 1 chromate in the compound. That would not work if there happened to be a subscript of 2 there, because that would double that concentration of the ion. And it's the concentration of the ion that you want to put in here. So I just put that as a cautionary tale that you don't just blindly take the common ion concentration and plop it right there. All right, so common ion problems, always decrease the solubility of a salt.